Bonjour à toutes et à tous et bienvenue sur Génération GPU. Aujourd'hui c'est la grande messe des nouvelles technologies qui se déroule à Las Vegas. Je vais bien sûr parler du Consumer Electronics Show 2025 qui se déroule du 7 au 11 janvier où l'excitation est à son comble. Nous avons l'immense honneur d'accueillir le PDG de Nvidia pour une présentation très attendue. La révélation des toutes nouvelles cartes graphiques GeForce RTX 5000, nom de code Blackwell. Ces innovations repoussent les limites du possible en matière de performance graphique et d'intelligence artificielle. Préparez-vous à découvrir une technologie qui transformera votre expérience de jeu, d'animation et au-delà. Sans plus tarder, souvenons-nous que l'avenir du gaming est à nos portes. Laissons le PDG de Nvidia nous en raconter davantage. Voici Jensen Huang.
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it. Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA. You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now. That was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS, the latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3, if I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look. Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders, one is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled, fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549. Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale, availability starting January.
Voici donc les specs des 4 cartes graphiques de la génération Blackwell annoncées par Nvidia lors de ce CES 2025. Passons maintenant aux performances. Tout d'abord, voici les performances de la RTX 5070 comparées aux perfs de la RTX 4070 dans 5 jeux: Far Cry 6, A Plague Tale Requiem, Cyberpunk 2077, Alan Wake 2 et Black Myth Wukong. Ici, les benches ont été pris en 2K avec tous les détails au max avec le DLSS nouvelle génération, le DLSS 4 rebaptisé la MFG, acronyme de Multi-Frame Generation, une exclue RTX 5000. Passons par la suite aux performances de la RTX 5070 Ti. Même jeu, même topo, toujours en 2K, mais cette fois comparé à la RTX 4070 Ti. Ensuite, on passe à la RTX 5080 comparée à la RTX 4080. La même chose mais en résolution 4K. Enfin, la RTX 5090 comparée à la RTX 4090, toujours en 4K. Voici les prix en euros annoncés par Nvidia des modèles Founders Edition. La RTX 5070 est annoncée au prix de 649 €. La RTX 5070 Ti, elle, est annoncée au prix de 884 €. Le modèle RTX 5080 est annoncé au prix de 1179 €. Enfin, l'ultra haut de gamme, la RTX 5090, elle, est annoncée au prix de 2349 €. Il est évident de noter que les modèles des les autres constructeurs, Asus, Gigabyte, MSI, Zotac, etc. seront plus chers. De plus, on ne connaît pas encore le prix des RTX 5060 et RTX 5060 Ti, ainsi que les modèles plus bas de gamme qui devraient être présentés par la suite. La disponibilité des RTX 5080 et RTX 5090 est annoncée pour le 30 janvier, tandis qu'il faudra attendre courant février pour le RTX 5070 et RTX 5070 Ti. Voilà, j'espère que vous aurez eu du plaisir à découvrir cette nouvelle génération de cartes graphiques de Nvidia, les RTX 5000 nom de code Blackwell, lors de cette keynote du CES 2025. Moi je vous dis à bientôt pour de nouvelles infos et vidéos sur le Facebook et la chaîne YouTube de Génération GPU. Je vous souhaite en passant une très belle année 2025. À bientôt les potos.